In this lesson, in order to practice what we've learned for shaders and stuff like that, we are going to create a raging sea only by using shaders. We are going to start from a plane and we are going to create that animation of wave and stuff like that. I have a good news, it's almost only things we already know, but it's kind of complex. We are going to start from this plane, we are going to make it wave, and we are going to colorize it, and we are going to keep controls over the parameter with the debug panel, right? It's the usual .gui debug panel. Okay, let's go. So right now all we have is a plain buffer geometry. The material is currently the mesh basic material. We are going to change that. .gui is already set. There is no light, no stuff like that, no other objects. It is just one simple plane, and we are going to create a raging sea with only that plane. It has already pretty much a kind of a subdivision. Let me check how much. Yeah, we have this as a subdivision. Maybe I can show you just the wireframe like that. All right, as you can see, we have a lot of details. Maybe that's too much, maybe not. Anyway, let's go. So first, we have to start somewhere. Let's change the mesh basic material with a shader material, all right? Not a raw shader material. I don't think we will be using raw shader material anymore. We are going to use the shader material. So let's go, shader material. I can show you something interesting, is that if you provide a shader material with no parameter, you get something. All right, it's because there is a default vertex shader and a default fragment shader, which is great. You can just put your material and get back to it once you want to develop better shaders. Then we are going to create the shader. So let's go. And you can open on the side. I will put, I think it's going to be kind of the same path. We are going to create a shaders folder with an S, because we can have multiple shaders in one project. And this time it's not going to be test, it's going to be water. Water, because you can have something for the sky, something for the clouds, something for the, I don't know, there is a pirate ship with an effect on it. I don't know, it's up to you. But in this lesson, we are only going to have a water shader, vertex and fragment. Then you can create the vertex.glsl. You can change the name if you want. And then the other one is going to be fragment.glsl. All right, it should look something like yeah, like this. Here is my folders, src, shaders, water, vertex.glsl, fragment.glsl. That's cool. How about you don't look at what I have right below and you create the vertex shader on your own. It's a good exercise. It's very hard. It's still hard for me to remember every matrices and stuff like that. But it's good to practice in order to remember the things we've learned together. So let's go. Let's try to write the shader. I will do it with you. So we start with a void main. All right, this is a function that will be called automatically. Then we have multiple matrices. The matrices are already imported because we are using a shader material, so we don't need to do uniform, mat4, stuff like that. No need. We can create variables. We're going to create multiple variables just like we did at the end of the first shaders lesson. So it's going to be vec4. Remember that you have to provide a vec4 because at the end we need to set the GL position, something like that. GL position equals something, and we have to put something over there. So we start with the model. Maybe you can just list the matrices. So we have the model matrix. I think we have the view matrix, and we have the projection matrix, and we need to apply them in that order. So we're going to create a vec4 model position equal model matrix multiplied by the position of the vertex, but we need a vector 4, so it's vec4 position, and for the fourth value we use 1.0. Then we use it on the view matrix, so I can call it vec4 view position. I think I'm the only one calling the variables this way, but I think it's good, like you can really understand easily with that. View matrix multiplied by it's going to be the model position. All right, we create the model position by applying the model matrix. Then we create the view position by applying the view matrix on the model position. And finally, we create the projected position. You can call it projection position maybe, by applying the projection matrix to the view matrix. And we don't need to convert to vec4 because there are already vec4, all right? From here, it's just vec4, vec4, vec4. And then this one, we send it there. I think I got it right, but I always do mistakes. I think I'm forgetting something. Let me check. Yeah. No, it seems fine. We will see later. We are going to test it anyway. So we will see. Just save. We are currently not using it. So let's move forward and we will use it, import it right after. For the fragment, sorry, I spoiled. We are going to do the same. So it's void main because it's the function that will be called, and it doesn't return anything. And it's not GL position, it's GL frag color like that. And we're going to provide a color. Remember color, it's 4 values, RGBA. It can be 3 value, RGB if you don't have alpha, but for the frag color, it's 4. And I don't know, let's put, what was the color? I can check in the code. So it's, all right, we're going to use the same color, 0.5, so not too much red. A lot of green and a lot of blue. Is this kind of purplish thing? Yeah, maybe. All right, I think I got it right. Be careful with the semicolon as always. And then we can import them. To import them, it's already inside the Webpack where the GLSL file are already supported by the Webpack configuration. You don't have to do it. We only did it once at the first lesson with the shaders. So the water vertex shader, yeah, it's because it's only for the water. And we put the path starting from the script here. So it's inside shaders, water, vertex.glsl. Like that. And we can duplicate it. So this one is going to be fragment. And this one is going to be fragment2, lowercase. And we can test them. Oh, not working. Like that. We can save just to make sure that everything is working. Yes, so currently we are just importing those. And because the Webpack is made like this, it just provides you the content as a string, which is exactly what you can see here. This way we can just write the shaders in separated files like we discovered in the first lesson. Then we can use them, finger crossed. So to use them, we have to use the vertex shader property and the fragment shader property, like that. Did I do it right? Yes, I did. Great. If you did a mistake, do not worry. It's perfectly normal. I almost did mistakes. I've been doing it for years and I still do mistakes here. So it's perfectly normal, but it's good to practice. So you understand, so you can do it faster. It's all about understanding and doing it faster. Anyway, if it's not working, pause the video and get back to the video once it's working. Okay, let's talk about what we are going to create exactly. We are going to create like a mix of big and small waves with different shape and be able to control everything. We always say that, but what's better than a sinus to create waves? All right, we're going to do something like that. The beginning is very similar to what we did with the flag. It's almost the same thing. We are going, just like we did something like that on the flag, then on the other axis, we are going to do exactly the same thing. So we are going, I have some drawings, you know, I like to draw. We're going to do like something like this. All right. We're just going to do a sinus wave. Maybe it's going to be like that. Maybe it's going to be just like that. We will see. But in fact, we are going to have control over it. So it's going to be whatever we want. All right. So let's go. This is my plane, by the way. And we are going to talk about each axis. You just have to project the image here. We're going just to draw on those like sides, this one and this one, in order just to visualize easily. So we want to create those big waves, and then the waves will be animated, etc. So let's go. It's not that hard because we already did it. What we can do is go into the vertex shader because it's about moving the vertices, and we're going to focus on the model position. All right. First, we apply the model matrix. Then we can play with the model position. We could have played with the position, the vertices, the base position first. You can do that. You cannot change this one, but you can create a new one. Like, I don't know, let's say new position equal like that, and then you can play with it with this new position and then use this position. But in this project I just want to first apply the model transformation so that my plane goes wherever he has to go and scale just like he has to scale, and rotate too, because remember that the plane, when you just add the plane to the scene, the plane is kind of facing the camera and we have to rotate it. All right, so first I apply model transformations and then I play with the vertices. Usually it really depends on what I really want to do. Anyway, and then this part you can really like short it and put everything inside the gel position. But I like to keep things clear, especially for beginners like us. That's cool. Remember that the model position, you have X, Y, and Z. If I increase the X, I can do like plus equal 1.0 and then model position, my bad. And then it goes to the X direction. If I do it on the Y, it goes up. All right, this is why we cannot see it anymore. But yeah, it did goes up. Okay, cool. I will write the axis on my drawing in order to help you understand what axis I'm talking about. So this is going to be the X, something like that. This is the X. And this is the, I don't have blue. I will use this cyan like that. So this is the Z going toward the camera, but it can be the opposite. It really depends on where your camera is. And then this is the Y. So this is the Y. Okay, that's cool. So we want to move the vertices on the Y, meaning that if I want to take care of this one, I don't want it to go there. I want it to go up or down. All right. To make the waves, you don't move on the side. You just move up and down. You can do an animation like on the side, but it would be more like the pattern on top of it with the foam or stuff like that. Anyway, it's another subject. So yeah, let's go. We are going to apply to move it on the Y. So we do something like model position Y plus equal, and we use a scene. And the parameter of the scene is going to be the X. This way we get waves. The more on the X, the more the waves progressed. So you will get something by doing that. So it's model position X. You can do that and just watch the result and you get something like that. So it's kind of working, but as you can see, my waves are way too big. Remember that the sinus is going, the amplitude of the sinus is from -1 to +1. And in that sense, -1 and +1 is a lot. So it's probably too much. So we have to play with its amplitude. So it's going to be the elevation for us and the frequency, because as you can see here, there is a huge frequency. We get something like, we got something like maybe that. All right, which is why we cannot see much of it. It's just like a huge wave, way too big. All right, let's first play with the elevation because it's way too high. And we are going to start by adding a uniform. As I said earlier, we are going to control everything about this sea, everything about the waves, the color, in order to create the perfect sea. So let's go to the material and add a new uniform. So uniforms. Big waves elevation. All right, you can choose other name, but I try to find the perfect name. We are going to have a lot of uniforms, a lot of parameters. So you better use my names for the parameters. And then you can choose a value. Remember that you have to provide an object with a property, a value property, and put the value inside of it. I know it's a little far-fetched, but Three.js need that. All right, great. So we just added uniform. We can now use it. So to use it, you go to the vertex.glsl. You import, you retrieve the value by doing uniform. You have to specify the type. For us, it's just a float, so float, and the name of the uniform. And then you can play with it. And because it's the amplitude, like the elevation, it's just the result of scene. So it's not inside the scene we have to do it, it's outside. So multiply by this. So it doesn't go from -1 to +1. It will go from -0.2 to +0.2. You save. All right, that's better. Cool. So we lowered the elevation. Great. Let's move forward. Create an elevation. Yeah, we are going to do something a little differently. We are going to apply a lot of things on the elevation. What we are going to do instead of modifying the model position y is to put everything in the elevation variable. So we're going to do float elevation variable equal move this part, this formula inside of that variable and use it right away, like that. It's going to be useful when we are going to colorize it because we are going to choose a color depending on the elevation. And the higher, the more of a color we're going to use, and the lower, the more of another color we're going to use. You probably know what we are going to use to create that effect. Anyway, we did the same thing. It's just that we put everything in an elevation formula. Yeah, looking great. We can move forward. Yes, and because we want everything to be tweakable, we are going to add this to that GUI. So let's go. We can do it after. We can call it like debug. It's not that important. So it's going to be GUI. We already have an instance of GUI. Add. We have to provide the object. So it's going to be water material uniforms, U big waves, elevation. All right. And then we play with its value property. So we want to tweak this value here. And we have to put mean. We are going to put a mean to 0 so that there is no wave. A max to 1. And we can put a step, the usual 0, 0, 1. And if you just do that, the problem is that it's going to be named value because the name of the property is value. So always provide a clear name if it's not already the case. Name, and I'm going to use just the name of the uniform so that I can find it easily. Oops. Like that. So sorry, it's a big line, but anyway, you probably know how to do this. We've been doing it a lot of time. So you get this. I can just let you see the line here. And then as you can see, we can control the waves elevation. It's starting great. We're going to do that. Most of the lesson is going to be that. And then finding the right tweak. So let's move forward. If I'm going too fast, just pause the video. We want to control the frequency. So currently the frequency is only on the X. We are moving on the Y, but we are using the X. So we get a wave like that. And because we are using only this one, we get the same wave here and the same wave here. All right. It's kind of sad. When you have a C, the waves can move in every direction. So we're going to do it also on this part. All right. And we are going to use a different, it's so hard. And we are going to use a different frequency so that we can have different shapes of big waves. Okay, cool. Because we're going to play on two axes, we want to control the frequency of both axes separately. We're going to create a U big waves. It's going to be frequency, I think. Yeah, big waves with an S. Frequency. And we are going to use a 3 vector 2. All right, because there is going to be two values, X and Y. I know it's going to be on the X and Z, but when you use the vector 2, it's X and Y. You don't have a choice. You can put the values I use, so 4 and 1.5. We will see what we get here with those. You save. No error. Great. Let's continue. In the vertex, we can get those. So it's going to be U big waves frequency, and I did a mistake. It's working, I know, but when we are going to try to use it, we are going to have a problem because we said float, but it's not a float, it's a vector 2, all right? So put vec2, don't forget that. This is a common mistake I always do. First, we are going to focus on the X only, just to see if it's working and we can control the frequency, because as you can see, we said 4 for the X, so we should have a lot more waves visible. So U big waves frequency, and here it's inside the scene, because this is the way of controlling the frequency. We multiply by U big waves frequency X, like that. Working great. See, we have more waves. As I said, currently we only have the X axis doing that. We need to do it on the Z. So we can do exactly the same thing. Hang on, it can be quite long. We are going to refactor this. But the idea is to do exactly the same thing. And because we multiply at the end by big waves elevation, whereas it's for the X or for the Z, what you can do, look at my screen, it's kind of hard. You can just take this part. So this is the part doing the waves on the X. And we are going to multiply this part by the same thing, but this time it's going to be according to the Z, and use the big frequency Y. Yes, because big frequency is a vector too. We only have X and Y. I know it's kind of strange to do that, but you don't have a choice. You want to do waves according to the Z, so it's model position Z. I'm talking about those waves. As you can see, it's on the Z, so it's those waves. But the U big waves frequency is a vector too, so you have to use the Y. You don't only have X and Y. So it's a big line of code. Well, it's the moment where you can do like multiple variables or add line breaks. I think I'm going to add line breaks. Let me check. Yeah, let's add line breaks right away, and I like to do it like that. Usually I do variables, but this time I want to show you that you can just do line breaks like that. All right? It's kind of the same thing. This is on the X, this is on the Y, and we multiply both by the U big waves elevation. By the way, we didn't like add them one to each other because it kind of looks strange to have waves and wave above the waves. It would look kind of strange. So we just multiply them and you get a more chaotic result. Yet again, you just have to test it. I just tried plus, it was strange. I tried multiply and it looked better. All right, I think it will be working. Yeah, see? Now we also have waves on the Z. This is the Z and this is the X. And we have different frequencies. Great. The next part is about adding the tweaks. So we can do that here. We are going to add 2 tweaks, one for the X, one for the Y. So let's go. I can duplicate the U big waves elevation. Be careful, it's not the same object because we want to do it on the X and the Y of the value. So it's going to be water material uniforms U big waves frequency value X. All right, there is an extra step because this is an object and we want to change the X and the Y on this object. Minimum 0, maximum 10. It's almost the same. I just changed the maximum to 10. Yeah, that's all. And then you can call it, well, what I like to do I like to take the name of the uniform and add X. It's kind of clear. When you see it there, you will understand that it's the X of the U big waves frequency. I just saved this one. It seems to be working. Yes, look at this. It's looking great. That's funny. And then you can duplicate it and it's going to be on the Y. And the name is going to be frequency Y. And you can control on the Y. It's the Z, but it's the Y of the U big waves frequency. All right, you have to choose. Anyway, you understand. Let's move forward. And we are going to animate it. Yeah, right away. Why not? It's not that complex because we are going to animate it just like we animated the flag. So let's go. To animate it, well, we need to change, to offset the U scene. Because right now we have, like, I don't know, something that looks like this shape. If we offset the U scene, we get, I don't know, something maybe like that. All right. And if we offset it again, we get something like that. And as you can see, it's kind of moving because we just add to the angle in the scene value. We just add 1, 2, 3, 4, 5. Then the scene will move like that. So we will do the same, but we are not going to put a very specific value like 1, 2, 3, 4, 5. We are going to send the time, just like we did for the flag, just like we did for animating JavaScript. Always use the time. It's good to have time-based animation because it's the same regardless of the computer, of the frame rate, of the frequency and stuff like that. So yeah, let's go. We're going to add a new uniform. It's going to be at the beginning because I like to have it at first because it's the base of every shapes, every animation, every distortion, stuff like that. So I put it first. It's going to be a simple float and we start at 0, like that. It's uTime. We just send the time to the shader and the shader, we will do whatever we want with it. All right, great. We are going to use it at multiple positions, you will see. Then you have to update it inside the tick function. Yeah, that's it. We already have the elapsed time, as well as I can just show you in the console. So it's just the seconds that passed since we refreshed, we reloaded the page. All right, good. So I can remove it and I can just update it. So water, update water. Yeah, you know what? Update water. And we do water material. We have access to it. There is no problem. Uniforms with an S. We want to play with the uTime uniform and we want to change its value. And we are going to assign the elapsed time. That's all. It's just kind of long to remember that it's the material uniforms, the name of the uniform, and we have to change the value, not the uniform itself. And once you understood that, you will be fine. So right now we are sending the time. We can fetch it right here. So yet again, I'm going to put it at the beginning because I like to see it first. So I know that the shader is going to change with the time. I save, no error, great. What I'm going to do is simply add it to here, like plus uTime, plus uTime. I add it to the scene so that my scene will just change in time. Look at this. And it's working. Look at that. It's looking great. We cannot see much if we are like right above. We are going to fix that right after, but still we have an animated C. It's a great start. And we did almost half of the lesson. It's going fast. Maybe too fast. Sorry if I'm going too fast. I'm just so excited with this project. We want to be able to control the speed of the wave. All right. They are looking great, but still, I think the speed is great, but we want to be able to control it. We will use the same speed for both axes. All right. You can do a different speed, like a speed for the X and a speed for the Z, but I tested, you can't see much of a difference. So we are going to use the same. So let's go. It's the usual. Actually, maybe you can just try, call it ubig wave speed and use it on the uTime. Now I'm going to do it myself. You can follow me. So it's going to be ubig waves speed. It's going to be a value a little like slower, 0.75. The speed is going to be slower. You save, no error. You fetch it here. So the name was ubig waves with an S speed. It's a float. It's just a float. And then what you need to do is multiply the time with those ubig waves speed. Just like that. See, it's slower. I can even lower a little more. And it's even lower. Obviously, we want to control it. Let's go. So I duplicated this one. I should not duplicate this one because it's a float anyway. So it's ubig waves speed value. And we will go from 0 to 4. And here we can just call it ubig waves speed like that. And now we can control the speed. See, it's fast. It's slow. Great. And we refactor. It's looking great, but we can't see much in the middle, and it's going to be worse after because we are going to add more waves, more details. You will see it's going to be good to look great, sorry, but we want to see here. What we are going to do is colorize. We are going to use a different color for the depth and for the surface. Like if the wave is high, it's going to be a color. If the wave is at the bottom, it's going to be a color. Like maybe we're going to have some purplish thing like at the bottom like this, and little less, little less, little less. And on the top, it will be something like that and little less. All right, like that. See, so we can see the depth and the crease and stuff like that. So let's go. I will remove this part. Okay. It's kind of a long process, but we already did that. It's just a little complex. First, because we want to be able to control the color, it's very important to be able to control the color. There is so many color combination and color values possible that always add the colors to your debug panel. Unfortunately, it's kind of hard. Remember that if you want to be able to tweak a color, you need to have like a very clear string color, like a string version of the color. So we need that, and we don't have access to that. Even if we create a color in the uniforms, we cannot access to a clear value of the string. What we are going to do over there, we are going to create a debug object. Remember this one? It's just to have a debug object. All right. It's just to be able to put a color property with just a string that will look like, I don't know, hexadecimal or stuff like that inside an object in order to be able to tweak it. I know it's far-fetched, but we don't have a choice right now. Maybe Three.js will update so that we have access to a property that will look just like we need. And if this property change, the color change, I don't know, maybe. So yeah, we are going to do it over there. I don't know, I can maybe create like color. Yeah. And we add debug. So it's debug object. And we're going to create a depth color. So we can choose any name here. So I'm going to use depth color. Use any color. I don't know how it's going to look. So this one is going to be blue. So the depth are going to be blue, like a deep blue. We are going to tweak it anyway. So it's 0000FF. So that's a deep blue. And then we're going to call the other one surface because it's more like at the top. So at the surface color. I'm going to call it, it's another blue, but a brighter blue like that. You can just save. We did nothing here. I mean, we created, oh, I did a mistake. What debug? I never asked for a debug thing. Yeah, be careful when you write debug. VS Code is trying to fetch a dependency from the Webpack that lets you do some debugs. If you see a debug thing at the top of your code, just remove it. Anyway, we did create those. We are not using them. We are going to right away. By creating new uniforms. So what I like is to separate things a little. So I have the time, which can be used for anything. I separate with the big waves. So it's a property about big wave. And now I have color things. So I just separate a little. Don't forget the comma here. We have the hue depth color. It's kind of the same name. We have depth color where I create a depth uniform. And the value, remember how to handle colors in Three.js in order to send the right thing to the shader. We need color class. Remember the color class? Yeah, we talk a lot about this one. This is the color class, and it's a great class because you can provide like any type of value. It will work. You can write sky blue, it will work. You can write HSL, you can write just the free value like RGB like that. It will work. Really, really useful. Great job here that they did. So new 3 color, so it's inside the value, and I'm going to use this value here. All right, so that I don't have to specify the value at different places on my code. So it's going to be like that. Then I duplicate the line. Don't forget the comma. The other one is going to be surface, like that. And I'm going to use the debug object surface color, like that. I just save, finger crossed, no error. If you get an error, just check your code and get back to the lesson. We can add those to that GUI. It's maybe too soon, but anyway, we know how to do that. It's a little different because we cannot use add. We must use add color because that GUI cannot understand that this is a color. It can be a string. So you have to say, all right, this is a color, add a tweak color. So it's not on the material, and this is the purpose of the debug object. We need something like that in order to create a tweak. So we're going to do debug object, and the property is going to be, we're going to start with a depth color, like that. There is no min value, there is no max value, there is no step. So it's kind of simple. It's just the depth color, like that. And I have my depth color here. You can try to change it, that won't change anything because we are not using it for now. Well, we can do that here. What we can do, let me check how to write it in one line of code. Yeah, it's going to be quite a long one. So what I can do, as always, if it's too long, I can just put like line breaks like that. All right. Name like that. And then I want to know, because if you change this one, I know it's not changing here, but even worse, we are not changing the uniform. We did use it when creating this new color, but once it's used, it's not linked. Like if you change this value, it won't change this one. We have to tell Three.js, hey, I want to change this value and apply this new color because the tweak changed. To do that, you can do on change. Remember this one? On change, we trigger this callback function, and then we are going to update the color. So it's going to be water material, uniforms. It's going to be the hue depth color, the value, and be careful, the value cannot just do something like that. All right, don't do it. This is a mistake. You cannot just assign something else on the value because the value is an instance of Three.js class. You cannot do that, but you can do set in order to update this color, this Three.js color. So when we added a tweak on the depth color of debug object, so we added a tweak on that. And when we change this tweak, we update that uniform, all right, this class here by using the set method on this class. We can do it for the depth color. We can just test. Like if I do that and then I change it, no error. So check if you have an error. I know it's not working yet because we are not using it inside our shaders, but we are almost there. What you can do is duplicate this part, call it it's not that it's surface color like that. And we're going to update not the hue depth color, but the hue surface color. I wrote it wrong. Surface color. And we are going to use the surface color from the debug object like that. It's exactly the same, but on the surface color. I know it was long. Maybe you did a mistake here, but you don't have an error. We are going to test it right away. In the fragment shader, because right now it's about colorizing stuff, we want to color the fragments that we can see on the render. So it's not inside the vertex shader, it's inside the fragment shader. Actually, it could have been interesting to do it in the vertex shader and then send the color to the fragment shader for slight performance improve. But no, let's do it in the fragment shader. It's almost as good. You will see later. Anyway, we can fetch them because remember that we can fetch uniforms, retrieve uniforms in the fragment shader, just like in the vertex shader. So vec3 hue depth color like that, and vec3 hue surface color like that. Finger crossed, no error, great. Remember that it's a vector 3. The color, a Three.js color like that, that will provide you, once transformed into a uniform, a vector 3. There is no alpha in it, it's just red, green, blue, which is why we have a vector 3. And what we are going to do now, just to have something to see, because we did a lot of code, is just to use the depth color or the surface color on the GL frag color. Remember that it's a vector 3. The frag color is a vector 4. So you can just use it on the first 3 values. You can do hue depth color R, hue depth color, don't do it, G, and hue depth color B. Or you can do, we are just kind of revising what we did before. X, Y, Z, because this is aliases. RGB, it's just like X, Y, Z. And because we just provide them in this order, you can do X, Y, Z. And because X, Y, Z, it's all the values of it, you can just do hue depth color. All right, maybe you knew we were going to do that at the beginning, but you can create a vector 4 by starting with a depth color and then provide a fourth value. And maybe we could have done the opposite, so it makes no sense here, but you can also put the vector, the small vector part at the end. It's not important. All right, great. Let's test this one. We have a blue water. And we can change the color and put whatever we want. We can do like a green color looking kind of radioactive. Anyway, we're not using the surface color, so it was just a test. You can test the use surface color just to make sure that the other one is working too. Yeah, it seems to be working. So we did send the colors to the frag color. Sorry, to the frag color, but using the fragment color, and we can tweak them. I know it's kind of long, which is why we're practicing this. But yeah, it's working great. Let's move forward. What we are going to do, and you probably understood that, because we want a color here and a color here, and we want to have like a mix between them here. So if my color is like deep blue here and light blue here, I want the perfect mix on both of them, and here too, and here too. We want to mix them, and we are going to mix them just like we did in previous lessons. So it's perfect to see that again. And we're going to mix them according to the elevation. Like if the elevation is low, we're going to take more of the depth one. And if the elevation is high, we're going to take more of the surface one. This means that we need to know the elevation inside the fragment shader. And we don't have it yet. We don't have this information. So we have to send values from the vertex to the fragment. We are going to use varying. Yeah. So varying, we are going to call it V elevation. Sorry, I forgot something. We have to say float V elevation. It's just a float because it's just moving up and down. As you can see here, we're going to use this one. So we created it here. We can update it. I like to update them like at the full end, like I do varyings. And I will do V elevation equal. I can just take this value here. I could have taken like the model Y, but I know I like to separate things, separate the logic. So I will just use the elevation. Usually when I have a varying name like V elevation, if you check my code, you will see a variable named elevation without the V inside the logic here, inside the vertex, usually. All right, it seems to be working. We get a warning as always because we are sending varying to the fragment but not using them. To retrieve the varying inside the fragment, you do the same declaration here. So it's going to be varying float V elevation. I like to start with uniform and then varying. Just like here, I did start with uniform and then varying. And in between, I can have attributes. We are not going to have attributes in this lesson. It's just kind of logical. And I always code the same way so that I can just get back to very old code and I will know where I am. All right, cool. So we did get it back. What we are going to do, let me check. Yeah, we can do the mix. Don't do it, but I will just show you the result. V elevation, V elevation, V elevation, just to show you if we can see something. And yes, we can see something. See that slight like stain here moving? It's the elevation. And we're going to have a problem because the elevation, it's not that high. The value is kind of too small and we're going to fix that. Anyway, let's do the mix. No joke here. What we are going to do is vec3 color, because we just want a color, so I'm going to call it color. I can call it like watercolor, but I'm inside the water fragment, so it's kind of logical. Anyway, I will do a mix. Remember the mix function, you have to provide one value, one other value they have to be the same type. It can be a float, a vector2, vector3, vector4, and then a third value. And the third value will decide on how much of this one or this one to take. If the third value is 0, it will be the first color, speaking of color. If the third value is 1, it will be the second color. And if the third value is 0.5, like right between 0 and 1, it will be a perfect mix of the first parameter, of the parameters, of the colors. So let's go. We have our depth color. We have our surface color. And we want to mix them according to the elevation. It's not the hardest function. It's just a mix between this one and this one according to this one. I really like how simple a mix can be. Anyway, let's use that color. Instead of the use surface color, I use the color. Finger crossed. Is it working? No, it seems like it's just blue. Is it? Change the surface color and use like a white, and use the depth color and use I don't know, like maybe something like, yeah, dark. See, we can see something, but we can't see much when we just refresh. And that's true. The problem, we just saw it earlier, is that the V elevation, it's going from, so it's multiplied by U big wave elevation, and U big wave elevation is 0.2. So I think that right now, our V elevation goes from minus 0.2. So that's a problem because it's below 0. So the value gets extrapolated below the depth color, and positive 0.2. And positive 0.2, where we are never going to get the surface color because we need 1 to get that surface color. So what can we do? Maybe we can do something like multiply by, I don't know, 3 maybe. Alright, looking better, maybe 4, 5, something like that. And then we can offset it like plus, I don't know, 3.0. Oh, that's too much. Maybe 0.5. Yeah, that's better. It's hard to find the perfect value. What we are going to do is add uniforms and add those uniforms to that GUI. As always, it takes time, but this is the perfect way to find the right value. So let's go. I will remove it. You go to the uniforms, and we're going to add, so it's about the color, so depth color, surface color. We're going to add color offset, just to offset the elevation value. We are not going to change the elevation, just the elevation value we get in the fragment that we use for the mix. So U color offset, value, I don't know, 0.25, and U color multiplier, just to multiply it, multiplier, and do 2, why not? I think it's going to be fine, let me check. Yeah, maybe. It's maybe not the right value. Anyway, we are going to be able to tweak them. The next part is about adding them to that GUI. So there was a comma too much. I'm going to use, because it's float, I'm going to to start with the big waves elevation. So it's after this one. I do them in the same order. Careful with the indent. So water material uniforms. The first one was color offset, I think. Yeah, that's it. Color offset. The value will go from 0 to 1. You don't need more. And you can call it just U color offset. All right. We added this. Oh, sorry. U color offset. It's just a float, just like the big waves elevation and big wave speed. And then here we added to that GUI. So it's not a color, stuff like that. U color offset, value, and change the name to U color offset. Don't forget to change the name. And we get something like that. We are not using it, but still it's working. And the other one is going to be color multiplier. So I'm going to change the offset by multiplier. I change it at both places. So the name of the object and the name inside the label of in the that GUI. And it seems to be working too. So it's showing that, oh yeah, you have to change the max value too. So max you can do 10. Yeah, this is better, so you can change it. Put a minimum and a maximum value that lets you really play with it and have good surprise. Maybe add a little more than what you can think about, and you might get good surprise. All right, we can use them inside the fragment. So let's go. I can just import. So it's uniform float U color offset, I think. Yeah, that's it. The same for the multiplier. And then what we can do is, instead of just adding it here, what we're going to do is create a new variable, because why not? So that we don't have like a huge line of code that we cannot understand. So we're going to call it mix strength equal. Don't call it mix because you're going to mess with the function that is already named mix. Don't use like the word like you cannot call a variable vec3 or mix or length. You're going to mess with things. And it's going to be the V elevation that we offset. So we apply the U color offset. So we apply the offset to the elevation. And this we're going to multiply it, yes, but the whole thing is going to be multiplied. So we put parentheses and it's going to be U color multiplier, and don't forget the semicolon. I just applied an offset, and the result I multiply it by the hue color multiplier, so the second one. We save. We can use this mix strength here inside the at place of the V elevation, like that, and it's starting to look better because the values were changed here. So it's 0.25 and 2. And right now what we can do is play with it. We can just change the value, and maybe we can find, I don't know, some so this is the one on the top. It's the depth color. Values get interpolated, so we get kind of a strange thing. But as you can see, I got this. I like this one. Maybe this one. Maybe it's too much, so I can just lower this one. It's starting to look great. Maybe like a deeper blue. Yeah, like that. And this one, maybe I can go, yeah, I like it this way. Let's lower the offset again. Yeah, look at these beautiful waves. All right, looking great. Sorry, I kind of lost myself here. Try values, have fun. Me, I'm going to use those values. So it's up to you. Find your values. I can wait to see what you are going to choose as the values. Try stuff. Wait for the end of the lesson to show me what you did on Twitter or maybe on the Discord. Anyway, here is my values. I'm going to use the same as in the lesson so that there is no surprise. So the first one, so the depth color is going to be 186691. And the surface color is going to be 9BD8FF. Okay, you can save. And then for the values here, the color offset is going to be 0.08, so not much. And we're going to multiply it a lot, so the values get, the values get extrapolated, but it looks great. Almost what I got before. That's great, but this is not like a raging sea with pirates battling on it. We need more details. And we're going to add small waves. We're going to use a Perlin noise to make the waves change in time, alright? Because Perlin noise is more chaotic. This one is too it's always the same pattern. It's not realistic. We need more chaos. And we're going to use a Perlin noise to do that. And we're going to make it change in time, alright? The idea is that we are going to add wave on it. This is our current wave, and we are going to do something like that. Alright? In every axis. More chaos. Okay, cool. So what noise are we going to use? Well, because we use was it Stefan Gustafsson? I think it was the Stefan Gustafsson Perlin noise. So we're going to use 1, 2, but this time it's going to be a vector 3 Perlin noise. But you could say that it's only a plane. We should use a vector 2 Perlin noise, just like we did in one of the previous lesson actually. Well, we're going to use the vector 3 because we are going to make it change in time. Meaning that the waves, if you just remove the big waves and you look at the small waves we are going to add, just look at them, you will see that they will fluctuate, it will be chaotic, they will change because they will change according to a third value. And the value will be the time. You will see the result shortly, you will understand. So yeah, let's go. We can do, so you can take the code. There is no surprise with this one. We have the permute. We have every functions we need. You can just take it. It's from the GIST. So as always, check the links panel. And it's the classic Perlin 3D noise by Stefan Gustafsson. So you can just take this one. We have the permute, Taylor, in squared, fade. You can just take this one. All right, not this one. Just take this one and use it. Actually, there is two. What's happening? All right, take it from the lesson. I don't know why there is two with the same name. So scroll on the page, take it from the lesson, and it will be fine. So let's go. I just took it from here. No surprise here. And just put it in the vertex because it's about moving the things. And I will put it there. And this is where it could be great to have like different files because see how big the Perlin function is. It's bigger than my own code. Yeah, that's a problem. Anyway, we're going to stick with it. So add it before your main function. You can save just to make sure that there is no error. Great. If there is an error, you probably copy something wrong. Check what you copied. And what we are going to do now is use that C noise. So let's go. We're going to use it there. and we are going to apply it on the elevation. So we already have the big waves, and we're going to do elevation and just add it. So plus equal. The name of the function is cnoise. All right, why not? You can change the name if you don't like it. And because it's a 3D Perlin noise, we're going to use vec3, and we are going to use the x and the z as parameters. The x and the z. So model position, let me check the code I did. Yeah, we can use Swizzle, so x, z. You can do like model position x, model position z, and then we have to provide the third value. But what you can do is model position x, z. You can do that, it's the same result. And then the third value, well, let's just start with 0. I just want to see something. All right, it seems to be working because we had something that did change. But the problem is that the waves look like even bigger. It's because the frequency is wrong. It's the frequency of this one. Don't do it. I can just show you a different result. If I multiply by 10, all right, I get that. And as you can see, the problem now is the amplitude. I think actually we can do that. But anyway, what I wanted to show you is that if you move the elevation down, as you can see, we don't have big waves anymore because we said that the big waves elevation is 0, so we cannot see them. As you can see, it's not moving because we put 0 at the third parameter. Here, what we can do is use U time, and you will see it right away. Move the U big waves elevation to 0, and it looks like that. It's chaotic. I know it doesn't look like waves. We are going to fix that, and it's way too high, and we had to put a frequency to 10, but as you can see, it's just moving on its own. It's like living because we use the third value of the noise. Anyway, let's move forward. So we're going to fix things just to have a great result and then add the tweaks. So we had this. I will get back to what you're supposed to have. And the first thing is that the speed is too fast because we are using the time, and the time has a like huge impact on the waves. It's too much. What we can do here is slow them down by multiplying the time by 0.2. Like that. Later, we're going to add a uniform and a tweak for this one. I just want to see better waves. Then the frequency is too small because right now my small waves are as big as my big wave. So we have to play with this part. This is controlling the frequency. Right now, I can show you the big wave. We wanted something like that. But we got something that was looking like that. So we cannot combine them. It will be a mess. So what we can do here is, let me check, multiply this part by a bigger value so we have more waves. So 3.0. Let me check. Yeah, that's better. All right. Right now, what we have is something like that. We are going to improve it anyway because we have a higher frequency. Great. Let's move forward. The waves are way too high. Indeed, we cannot see the big waves anymore because the small wave or the elevation is way too high. What we need to do is just multiply the result of the C noise, which goes from, I don't know, maybe minus 0. Maybe minus 1.23. It's not clamped. Like it doesn't go from 0 to 1. It doesn't go from minus 0 to positive 0. It can go even further. This is one of the specificities, the features of the Perlin noise, at least this one. So what we are going to do is simply multiply it by a smaller value, like that, 0.25. Oh, now it's looking great. Not realistic though, but still better. Okay. Yeah, what we want, I can show you. Currently, we have something that looks like that. All right. It looks something like that. If I do it higher, it looks something like that. Okay, that's cool. But what we want is more something like that. Maybe small ones, big ones, small ones, big one, small ones, big ones, small ones. Those are waves. I like those kind of waves. I don't want those like round waves. I want to see like trough and crest, like trough here and crest here. What can we do? Well, we are going to simply use apps, because right now I can show you maybe on the side, we have something like, let's say we have a 0 value here. We have something that looks like that. All right. What we are going to do is take those one and put them, I will use another color. So this one, I want them to be like that. And this one, I want them to be like that. And this one, I want them to be like that. And this one, I want it to be like that. And this way, see the shape we get. So if it's under, we get this, 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 this. Oh, sorry. This, this. And this one will look just like we want. All right. So everything being positive has to be negative. So it's kind of the opposite of apps. What we are going to do is the opposite. We are going to say apps. So it will look something like the exact opposite. It will do something like that, 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 that. And then we are going to use a minus on it, and we will get that, 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 because we are going to invert it. Like that, and we will get our wave shape. So it's the purple one. This is the idea. So what we're going to do, let me check if we do it this way. Yeah, it's going to be a big line. So what I say is to move, to make sure that we have positive values, so that the ones going below the surface are then going up. So it's almost the shape we want. You can test it. So apps, like that. We put everything in apps, and we get that. And this is the opposite of what we want. Now we have something that looks like that. We want to revert it to have something more like that. What we need to do is simply minus instead of plus. And we get this. And it's looking much better. See how realistic this can get? It's looking great. So let's move forward. We are almost there. Yes, we did that. It's looking great, but we can do better. If you look at the Regency, like in movies, stuff like that, you can see that there is more chaos. And it's not that regular, because right now it's like really regular. Like you can see a frequency. It's kind of random, but still you can see a frequency. What we are going to do is add more Perlin noises, but with smaller frequencies. So we have something I can show you again with a drawing. We have something like that. And we are going to add more things in order to get something like that. It will follow the first one, but we will add more different frequencies like that. And even more like that. So we apply more Perlin noise at different frequency, and the end result will be just so realistic and so chaotic. It will just look great. How many do we want to apply? Well, we don't know yet. What we are going to do is be able to tweak how many iterations, how many Perlin noise we apply. So yeah, let's go. Because we want to be able to apply 1, 2, 3, 4, 5 Perlin noise with different frequency, we're going to use a for loop. Because yes, you can do for loops inside GLSL. Sometimes you will have troubles with it, but we're going to use it the right way and it will work. So let's go. Right before adding the first, so our main Perlin noise, we're going to do for float I equal 1.0, I inferior or equal to 3.0. As you can see, I'm using floats. I plus plus. You can just do that with nothing in it, just to check that it's working. It's not. Oh yeah, I put a comma, so it's semicolon, so it's always good to check. And then what you can do is move what you did here inside of it, right here. Strange result. It's kind of doing 3 times, so it starts at 1. I know we didn't start at 0. You will see why. What I wanted is 1, 2, 3. So that we can apply 1, 2, 3 Perlin noise with different frequencies. So this is why I started at 1. And as you can see, we get this really strange result because we are applying the same Perlin noise with the same frequency 3 times. So we need to fix that, but it's working, which is great. What we are going to do now is use that I to control 2 things. We're going to control the elevation because as you can see on my beautiful drawing. The first one has a huge elevation. The second one has a small, so it's the first one is the green one. The second one, the orange one, has a smaller elevation. And the third one has an even smaller elevation. If I add more, I would have to do the same. So smaller, smaller, smaller. But the other thing that changed between those is the frequency. The first one has a huge frequency, something like that. The second one has a smaller frequency. I don't know, maybe something like that. And the last one, the third one, has a very small frequency like that. All right. So it's about the elevation. It's about the frequency. And at the end, we should get a good result. And this one, oh, it's not purple. My bad. All right. It's looked like this. Okay. Let's go. What we're going to use is use the I inside the frequency and the elevation. So the elevation, we're going to start with the frequency. So the frequency is controlled here. So we're going simply to increase it. So the first one will have a low frequency, and the next one will have a higher frequency, which will make the waves look smaller. And the next one is going to have a higher frequency, which will make the waves even smaller. So we just multiply because we have I equal 1, I equal 2, I equal 3. We just multiply this part. We save. Oh, it's looking great. But the smallest waves are as high as the main wave, as the first wave. So what we can do now is use the I to lower the elevation, and it's this part. All right, this is controlling the elevation of the wave. So we do divided by I, like that. Look at the result. Look at this. Look how great it is. It's looking really good. But if you look closely, let me check. Yeah. If you use just 2 iterations, we get almost the same result. We can see a difference, but we can see much of a difference. I can put back the 3. Yeah, there is a slight difference. We should be able to see more. The problem is that we don't have enough subdivision in our plane. We already have a lot, but we are going to crank it up even more. So it's this one. Use this value. So it's 512. You can put anything you want. You can put like 500 if you like round values. And yeah, as you can see, it's even better. You can really enjoy small details. And you have so much details that you can even add more here, because this is controlling how much iteration, how much pairing noise we use. Don't use too big values because pairing noise are bad for performances. Maybe use 5. Look at this. Look how great it is. I really like this one. I think 4 is more than enough. And maybe your computer is starting to blow like, so careful. But it's okay, as long as you can run this experience on low-end computers at 60 frames per second, it's great. And we only have this in our scene, so it's okay. So that was great, it's looking good, but right now what we need to do is add controls, because we have like random values we put here. So this one, we want to be able to control it. This one, which control the elevation, this one that control the speed of the waves, and this one that control, I think it's, no, this one is the elevation, my bad, and this one is the frequency. So let's go. We can move to the material, and because it's a different party, so we had the big waves, we have the depth, and right now we are going to have the small wave. You know what, let's put the small wave between the big wave and the color. It's kind of logical because this is more about the vertex and this is more about the fragment. I like to have things in order. So it's going to be small waves, elevation. You know what? We're going to put everything in one go. I'm going to have only floats. Great, that's easy. It's the same frequency on both axes. It would look strange to have different frequencies. Maybe not. Well, you can try using a vector too. We have the wave speed. It's 0.2. Just use my values to start with, but you will be able to tweak them anyway. And iterations, and we're going to use 4. Yeah, we did use 4 at the end. So 4.0. I don't know why I put a point something. You can just put 4. All right, we are not using them. Before adding them to that GUI, let's do things slightly differently. We're going to use to retrieve them in the vertex. So everything we did here was in the vertex. and we can do uniform float like that. All right, just retrieve them. I save, still no error, but I'm not using them. So in order to use them, well, you can just put them at the right position. Be careful, I have a lot. What I like to do is just copy them in order to have them visible somewhere. So the iterations should be here. Yeah. The speed has something to do with the U time. So I think it's this one here. I can remove them once I'm done. The frequency is here. Yeah. And the elevation is at the end here. That was a lot. Can I just, let me check. I cannot do line breaks here. Well, I can do something like that. All right, let's do that. I will add a lot of line breaks in order to keep everything in one screen. You can do the same if you want. So this is the first value. This is the first two values. This is the second value. All right, I put it there. I put it there. And this one is going to be there. That's another way of writing it. Anyway, you have everything here. Pause the video if I went too fast, sorry. You can save, you get, it seems like the same result, but now we are going to be able to tweak them. Like if I change the elevation, I put 55, yeah, it's working, great. And if I want less iterations, smoother C, I can do 1 instead of 4. What we need to do now is add those to that GUI. We are almost there. So no surprise here because it's just floats. You can just duplicate one you like the U big wave speed. I'm going to duplicate it 4 times because I'm going to use those 4 here. So it's always good to keep things in order for those kind of reason. So see, I just duplicate the U big wave speed and I use my U small waves elevation, frequency, speed, iterations. Be careful though, the parameters are going to be slightly different between each one of them. So for the small waves elevation, we don't need a lot. So it's going to be from 0 to 1. And don't forget to rename it like that. I can rename all of them right now. So it's going to be like that. So I just renamed the labels we are going to be able to see here. The second one, we have min 0 max. So it's the frequency. Yeah, we can have a high frequency. So 30 is going to be fine. It's really precise anyway. That's not a problem. Then the speed, yeah, from 0 to 4, sorry, why not? All right. And the last one is important. It's from, let's say 0 to 4, because more than 4, we can't see much. Maybe you can put 5. Yeah, actually, I did put 5 here. So 0 to 5, you can see be above 5, but if you want to play, well, you can play with it. Let's put 8. Don't burn your computer. But the important part here is this, the step, because it's for the for loop. All right, we want to go from 0 to 2, 3, 4, 5. It's not 3.5, 4.7 or something like that. So we just put a step to 1. Did I do some mistakes? No, it seems okay. So it's the small waves. It's those one here, small waves, elevation, frequency, speed, iteration. And let's try it. Oh yeah, look at this. We can have like a really small one with a small elevation, or a huge elevation and big ones like that. You can do whatever you want. The speed, see the variation? It's too much. Let's just reduce it. Oh yeah. That's looking great. I have to stop playing with it. You can play with it, me no. Then we did that already. All right, that's the end. As you can see, it's looking really great. You know what? Let's put it in full screen. Let's have some fun. I don't know, maybe we can do like some kind of crazy thing at the depth. Yeah, I like purple. You can do some radioactive stuff. Maybe I can do that. Oh, look at this. It's looking great. Maybe more reddish. Yeah, this one is looking cool. Like it's almost lava. Maybe it's going too fast. Yeah, I want it slower. The speed is too fast too. Yeah, the elevation maybe. Like that. You can do whatever you want with that. It's up to you. Have fun. Send me your result. I want to see the waves you made. Try new parameters. Anyway, let's get back to the lesson. It's the end. Yeah, some ideas. You can add foam because it's kind of too regular. When you have water merging with other waters, you get foam. So maybe you can try to add foam. You can try to enlarge the plane just to see what you get, and maybe enlarge it enough so that you cannot see the edge. Maybe change the background, so the clear color to a more appropriate color, and then maybe add fogs on it in order to hide the edges that are too far. How do we add fogs? Well, you will have to do it on your own, because you cannot just add fog on the scene and hope it will work with your fragment shader. You will have to implement the fog on your own. It's not that hard, but it's new. So you might spend, I don't know, maybe 1 hour on it, maybe 2, and don't find the answer. So try it. Try to add fog. It's the distance to the camera. You will have to send values from the fragment to from the vertex to the fragment, stuff like that. I won't help you on this one. I won't do it with you. It's already a great exercise, pretty long. Anyway, send me the result, and I will see you in the next lesson.